we're going over, like, first of all, I want to review the string class with you guys because it doesn't seem like everybody really understands the syntax or, like, how to use the function. So I'm going to review that today. And then I'm going to go over functions. So we'll understand how do they work and how do you make them. Okay. So, the string class. As I said before, the char is a primitive data type. It can only store one piece of information about itself, and it can't piece together anything, right? So we use the string class in order to piece them together. So how do we create a string class? So first, we have to know the constructor. So do you guys know what does the word constructor mean? No, okay. So a constructor basically means how do you create an object in computer science, right? So in this case, we want to create a string object, right? So in this constructor, all we have to do is just write what data type it is, which is a string, and then we give it a name, right, or a variable name. So what this does is it allocates memory in your computer, and then what this does is it creates a name for it to be called upon, right? And then what you can do is you can assign it a value of Daniel or something like that. Or if you really don't want to, you don't even have to set the equals to. You just have to do the string real name. So what does this do? More specifically, that's very close. You guys can talk to each other. Remember what I said? When I ask a question, just instantly talk to each other. Okay. I'm going to wrap it up real quick. Okay, Ariana. Or no. Wait, Ariana, right? Yeah, okay, I'm sorry. Your sister was talking to me the other day, so then it's just, sorry. Okay, anyways, but yeah, so what's the first part of the thing, dude? String? Okay, more specifically.
It's a string name.
Very, very, very close. So whenever you see the variable type being defined here, that means the computer's telling itself, I'm allocating this amount of memory for this string. Okay? So just remember that. Whenever you see a variable type being declared in front. Okay? Okay, so does real name have a value here? No, right? Okay, so real name, yeah, it isn't set to equal anything. So how do we, so this brings me to input. How do we input values from a string? So we've got two ways, and if you guys were here earlier, you guys would have reviewed it, but there's two ways. First of all is cin. So you can cin a value for real name. So you do cin, two greater than signs, and then real name. So what does that do? It takes the first string before the space, right? So if I did hello world, if I type that into the console, then and I did cin, it's only going to take hello because that's just how the string class works. It's only going to take the first word before, or the first whatever characters before the space, right? So what if we want to get the space and everything, right? Because that's more useful. Because I want to be able to give it hello world. So what we do is use this function, right? Get line. So you guys know functions in math, right? So what do you do for math? How do functions work in math? Jack. Exactly, right? You put something in, you get something out. All right. So get line. What does it need to take in? It needs to take in two things. The first thing it needs to take in is how am I going to actually be able to take this variable in, right? So that's cin. Cin is how the actual mechanics of how we're taking it in. And then the second thing it needs to take in is what are we putting it into, right? So then we want to put it into the memory space called real name, right? Is that clear? So talk to your neighbor and explain to them what does get line do, okay? Alright, so I'm going to wrap it up real quick. Okay, so basically getLine, what it does is it's better than cin because it can take in an entire string, including the spaces, including all the characters that you might want to. What are the two things I need to give it in order for it to give me a string? Or not really give me a string, yeah?
A way to put it in.
Exactly.
And also the name of the string.
Exactly, name of the string. Okay, so that's real name. So output. Output's pretty easy, right? I mean, there's only one way we know how to output with C++ or anything. So, and that's cout, right? So in order to do cout, you do cout, 2 less than signs, and then you can put this string in here. But what if I want to add on to that string? What if I wanted to add on like an exclamation mark, or in this case, hi? You guys kind of see how we do it, right? So if you want to add on to it, what you do is you add 2 more less than signs, and then you just put it here, and then you can, this is called concatenating a string. So you're adding the string together onto more things. Is that clear? Okay, make sure you guys tell me if you guys aren't sure, okay? Or like just talk to your neighbors instantly. I don't care if you guys are like kind of whispering and trying to understand a concept, because that's how you learn, okay? Alright. So, obviously, the string class will be pretty boring if we can't do anything to it, right? So the nice computer scientists, as they were, they created a couple functions for us to use. So the first, not really function, but first ability that you can do is get a specific character in a string, right? So how do we do that? So we use this format, right? We have the name of the string, and then right next to the string we do brackets. So this is actually called an operator in computer science. So what else is like an operator? It's really easy.
911.
That's not quite, not quite. You guys know 4 operators very, very well. You've been using it since elementary school. Trisha. Exactly, those are called operators, right? So basically what the computer scientists did was they defined what the operator does, because technically they're just symbols, right? So what actually goes behind them has to be programmed. So it has to be programmed that when you type in a multiplication symbol, it multiplies. It has to be programmed that when you do a slash sign, it has to divide, right? So in this case, when they did name bracket, what this does is it gets the character whatever's in between these 2 brackets, right? Okay, so what is this going to get if name was Daniel? So what character is that going to give me if the name is D? Annie. D, right? Okay, why does it get D? Like, what is 0, right? 0 is kind of weird. Well, in the string class, this is just how they did it. So index or positioning of certain characters is different from which number they are. So if I had, okay, so this is my string here, right? I'll just, but then normally you would number it off like 1, 2, 3, 4, 5, 6, right? But the computer scientists are kind of weird, and they changed the number, like which number letter it is, to be different from what position it is. So the position of a letter is also called index. So the index actually starts from 0. So this is a key thing to note in your Pig Latin projects, because if you want to take the first letter off of the front, what are you going to call? Are you going to do name 0 or name 1? 0, right? Yeah, okay. So that's how you use the bracket operator. Okay, now how do you use the substring function? Talk amongst yourselves, and then I'll call on people. Okay, so I'm going to wrap it up real quick because I have a lot of material to cover today. So substring, first of all, what is a substring?
It's part of a string.
It's part of a string. Okay, great. Yeah, so it's a part of a string, right? Just break the word up. Sub equals part, and then string is a string, right? So it's part of a string. So what does a 0 mean here? Nor. Huh? The first letter, right? The first position of the string, right? Okay, and then what's 3? Huh? The 4th letter. Not quite. That's the positioning. But then in this function, what does it mean? Vishal. No.
What's the last letter of the substring?
Last letter of the substring. Very, very close. That is very, very close. It's okay. Don't be afraid to get these things wrong, okay? I just want you guys to talk. Over here, what does 3 mean? Exactly. How many letters it takes, right? So I could have changed this to 1, and then if I have the word Daniel, what it's going to do is going to look for index 0 or position 0, start from A, and then go 1, 2, 3, and then it's going to store. No, don't. Okay. 1, 2, 3. Yeah. Sorry. Don't listen to this. So what it's going to do is it goes to that position first, and then it counts 1, 2, 3. Okay, 3 letters. I'm going to store it into another string. called like of this thing. Okay, so it returns to you a string. And then why do I do name dot? Flo.
Because name is the name of the string, and you need to say what string.
Exactly, that's the key, right? So computers are dumb, right? You have to specify exactly which string you want to or not concatenate, but shorten, right? In this case, substring. Okay, so push back. Talk amongst yourselves, and then I want people to tell me. Okay, I'm going to wrap it up real quick. Okay, so over here, what do you guys think it does? That's another space. Very, very close. You're so close, so close. It's okay. Cole, do you have any idea? No, it's okay. Name dot push back. What does push back imply? Not quite. Not quite. It's okay. It's okay. Get it wrong. I'd rather you get it wrong than say nothing else. So that's good. Actually, to encourage you guys to talk more, Brittany, can you hand out sunglasses and stuff from that bag? I brought it for a reason. Yeah, Connor? Not quite. Nope. Why would I have a B in there? Right? Okay, Jack. Exactly, it adds B to the end of the string, right? So if my name's Daniel right now, what's going to happen is if I do push back, it's going to add a B to the end of it, right? The reason why it's called push back is because it thinks of it in terms of memory space. So, for example, Daniel right now takes up this is not true at all, but Daniel takes up 6 bytes. 6 bytes of memory right now. Okay, but then if you want to add something, what do you need to do? You need to add one more. So you need to push back the memory space. So you need to add more memory space. So that's why it says push back, right? So it means pushing back the memory space to give it more room. And then whatever's inside the parentheses, that's what you put in order to add. Is that clear? Or tell me if there's something wrong. Or talk to your neighbors real quick just to summarize. Okay, so come together. So hopefully you guys understand what it does, right? So basically what it does is it pushes back the memory space and then it adds another letter to it. Okay, so what does pop back do? Ryan. Exactly. So why do you think it's pop back? Think of it in terms of memory space, right? So pop back means I'm going to, instead of pushing the memory space, I'm going to pop it back. I'm going to, pop it off, I guess, whatever. It's kind of hard to describe it. So what it's going to do is it's going to take off that thing and then make the memory space less. Because the string class, because you guys know how I talked about primitive data types take up specific amounts of memory, right? The string class is unique in that it can change how much memory it takes up. So in this case, pushing back increases the memory, popping back decreases the memory. Is that clear? Okay, cool. So name.size. Name.size is pretty self-explanatory. Basically, it gets the size of whatever string you're dot sizing of. So in this case, it would return 6. Okay, but what's the key thing about all of these? Does it actually give you anything? Yazia?
I'm just asking, technically isn't that the same as length?
Length?
Or not length?
I think so. I think it's the same. I don't know why they have different. I don't have different. They also have some other weird ones. I don't know why they give a bunch of weird. Or length might be, it starts with the index, so then it's going to be one shorter. So sometimes it's useful for that, but I don't know why you wouldn't just do size -1. But anyways, yeah, so that's irrelevant. So what's the special thing about all of these that, what about the values? It's okay, yeah, sorry. Am I sure? Yes, okay. Okay.
It makes the name longer or shorter.
Okay, no, that's a very good observation actually, right? But that's not what I'm asking. But that's really good. Jack. Exactly, that is the key, right? So you can call all these functions, but they're useless because you're not storing it anything. So how would we store these things? Jack, you've talked a lot. Sorry. Dang it, you.
Equal to a variable.
Yeah, you make it equal to. So what kind of variable would you make it equal to?
Character.
Which one? Which one of these would you make it equal to a character? Talk to your neighbor about this.
First one. Yeah. Get a character.
Or, no.
Yeah, the first character.
No, the first one.
All right, over here. Akshar, right? Yeah.
I need help.
Need help? That's good. I like that. I like that.
The first one. The first one.
Why? Hint.
It gets it, because 0 is like the first one, because it's like 0.
Yeah, so whenever you do this operator, it returns a char, right? So you want to store this inside of a char because that's what it returns. Okay, what would you store this with? String, right? Okay, what would you store this with? String. Or would you even need to store this?
No.
No, right? Because what you're doing, you're changing the string, right? What about this?
Nothing.
String.
Nothing.
Nothing, right? Exactly. There. What about this?
Number.
Ah, who said string? Raise your hand. It's okay. Don't be afraid. Okay, Brittany, give something to all these people. Raise your hands high. Raise your hands high. Whoever said string. And then you can't change your answer. Anyway, but yeah, reason why this isn't in a string because it tells you how long the string is, right? It gives you a number. So when you can store it either in a double or an int. Okay? So yeah. Alright. Alright, so pig Latin projects. Raise your hand if you finished your pig Latin projects. Awesome. So I want all of you guys to come up here. You can bring your laptops too if you want. So now I'm going to talk about functions. So as Jack said, functions in well, he didn't say this, but like functions in math and some functions in computer science are very similar in that you put something into the function and then it gives it something else. So in this case, I input a small light green triangle, I put it through the function and it gives me a big darker green, or yeah, darker, is it lighter? I can't even tell. But it gives me a different colored triangle there, right? So that's what the function does. It makes it larger, it changes the color, right? So this automatically makes you, so basically it needs to accept an input and then it gives you an output, right? Input, output. Alright, so the question is, what can you input into a function in computer science? Well, you can input any variable type. So you can give it a bool, you can give it a char, you can give it a string, you can give it a int or double, okay? Or actually you don't have to give it anything if you want. And I'll go more into that later. And then what can you output? Which is the same answer, right? You can give it, it can output int, bool, char, or nothing at all. But does it have to be, do you have to output the same thing as you input? You guys can talk to each other. Okay, over here. Ramya. Yeah, you don't have to output the same thing, right? So what makes your function work, like what you have to input into the function doesn't necessarily mean what it has to output, right? So just to make that clear. So. Alright, so why do we even need functions, right? So functions in computer science, it's a way for computer scientists to break a large problem into several smaller problems. So, for example, I'm hungry, okay? How am I going to break that into a couple smaller problems or functions, right? So I'm hungry. Okay, first thing I check, what time is it? If it's lunchtime, then I want to do something, right? So I might have a function called is it lunchtime? So it'll check if it's lunchtime. And then second of all, and then another problem is do I have money? Because without money I won't be able to get food. So I have another function that checks do I have money, right? And another function probably asks do I have a way to get food? So does that mean I have a way to get from point A to point B, or do I have food in my house, right? So something like this is showing you how to break a larger problem into a smaller problem. So I want you guys to talk to your neighbors and tell me what kind of functions would you come up with for a game of tic-tac-toe? Alright, I'm looking for functions for a tic-tac-toe game. So, over here, give me two functions. Yeah.
Do you have to put something to stop them from winning? Or are they about to win?
No, it's just a tic-tac-toe game. What kind of function would you need?
Yes, that's what I'm saying. So it's, first of all, I have a prioritized list of spaces. first thing would be,
You're thinking from an AI perspective. I'm just talking about somebody running the game, right? But no, that's a good way of thinking it. That's a good way of thinking it. Yeah, Nora? What spaces are open? So then you have a function called open spaces, right? Okay. Cole. Give me another function. No, it's okay. What does it take in order to make a game? Sure, 2 players. That's a good one. Give me another. What does it take in order to check if you can play a game? Yeah. Or so how about functions that would determine whether you win or lose? Yeah, exactly. So you have a function called did I win, right? So then that would check if there's 3 in a row, right? Okay, over here, two more functions that would make my tic-tac-toe game work. Jeff? Yeah. Well, yeah. Check if the board is all filled up, and they said that too. It's okay. Let's see. Ryan. 2 functions.
Like if it's like player 1 for the turn.
What would you call the function?
Turn.
Yeah, turn order, right?
Oh,
No, that's
okay.
that's a good one. Okay. Okay, 2 functions for a tic-tac-toe game. Oh, come on, guys. I give you guys time to talk, too. Simran.
Maybe if like the person puts an X or O, like if they put an A or something, you can say it doesn't work. You like to check what they put in.
Yeah, no, that's a pretty good function. So you're checking if it's a valid input, right? But keep in mind, all of you guys are talking about how a function should work. I want you guys to tell me what is the function in the first place, right? So like, give it a name or something like check correct input or something like that. But yeah, wait, Cole?
Like if you personally were creating a function, a big function that was going to run a tic-tac-toe game, like how would you implement every single function so that it actually works? You just think about it like.
This is what you always have to do whenever you're tackling a big project, right? So in college, they asked us to create a challenging problem for yourself, and since I already knew some computer science, I got really bored and decided to make a text-based Pokemon game, right? So how did I tackle that problem, right? So first of all, I need to think of all the different parts of a Pokemon game. So there's Pokemons, there's players, there's battles, there's the world. Gym leaders. I didn't have that, but I had all these different parts. So my first job is to create all of these different parts and then tell them what they need to do. So a player, what does a player need? It needs the ability to store Pokemon. It needs the ability to move around. It needs the ability to do all these things. So this is what you need to do in your head before you attack a single problem. So then you're dividing it up into smaller parts, right? So is that kind of clear? Yeah, so this is the thought process you need to go through every single time before you actually attack a problem. Okay, so yeah, exactly. So a tic-tac-toe game, as you guys saw, you need a function to say if you won, to say if you lost, to say if you have open spaces, to say if you've got the correct input, and these are all great. So then this may seem like a lot of functions, but this is what it takes in order to make a game, right? So you're starting to think like a computer scientist. Okay, so it's kind of useless for me to talk about functions without actually telling you how to make them. So in this case, I don't know if you guys can see that at all. So this is how the syntax works, and I'll be posting this on my website too. So first, you have to say, you have to tell the return type. So do you guys know what does return type mean?
what is it about Alex?
What value does it?
What output, right? What type of variable is it going to output? So for example, I want to create a function called add, right? So the first thing I do is, this is the return type. It's going to return an int at the end, so that's what it's going to output, okay? And then the second thing I write is the name of the function. So in this case, I'm adding, so I'm going to call it add, right? So, and then you have parentheses, right? Inside the parentheses, if you guys notice about the getLine function, whatever you put into that, those are the parameters, right? So these are parameters of the function, and then within the parameters, you have to define what kind of variable type it is. Are you guys following me so far, or are you guys lost? A little lost. Okay, so talk to your neighbors about it. Explain to me, why do you need these things? Or what are these things? Okay, I'm going to wrap it up real quick. Okay. Yeah?
So then also, wouldn't you be able to call this just by putting add, parentheses, then number?
Yeah, that's how you call on it. I'll go more in depth on that, but yeah, that's exactly how you do it. So this is what we're doing right now is creating a function. So right now, what these two things are inputs, right? These two variables, right? So first variable we need is an int, right? Because if we're trying to add something, we want to use something to add with. And then for what you have to do is you have to define what variable type it is. So first you say it's an int, and then you give it a name, right? So is this part clear, or are there still questions on that? I don't know if that's a yes or a no. If it's a no, talk to your neighbors. Okay, I'm going to assume that's a yes. So if you guys don't get it, I'm also going to have a worksheet up soonish that's going to be talking about this. And make sure you guys are actually like reading and doing the worksheet too. Like you don't have to, obviously, but it actually does go in depth about how all this stuff works, and it helps you, just another reinforcement method for how all the syntax work, especially if you're coming from a different language. The worksheets are extremely helpful for you to get used to how C++ is written. So yeah, okay, so within the parentheses, you're going to talk about what type of variable you want to input and the name of the variable you're inputting. So then after that, you have two curly brackets, right? So curly brackets represent how much of the function is what you want, right? So what you need is, you need a return. So this is what you're returning. So whatever you're returning has to match whatever is up here, what you defined here. So in this case, since x and y are both ints, it matches the return type. You guys understand that? Okay. So what this does, it's going to return the value of x plus y, okay? And then, but you don't necessarily have to do just one line, because not all programs you can just solve in one line, right? So some functions you have to do multiple lines. So in this case, I do the same exact thing in adding int x and y, and then what I do is I create a new integer within the function, right? So this is exactly how you would code in your main function. You do int z equals x plus y, and then you return z. Why does that work? Okay, so, okay, quiet down, real quick. Okay, so when we're returning something, what does it have? What do we have to return? Nora. The output. More specifically, what kind of thing do we need to return? Hint. Look at the beginning. Ramya? Huh? An int, right? So whenever you return something, it has to be the same thing as whatever you defined up here, right? So up here, I defined that I'm going to return an int. So I better be returning an int down here, okay? So do I do that here? Yeah, I do that here, right? I created an integer called z, and then I'm returning z, and z is an integer, so that matches up with int. So you guys, whenever you're making functions, you want to make sure these two things match up, okay? So why does this work? Exactly. When you add two integers together, it's still an integer, right? So this isn't violating whatever you say here, right? So make sure these two match. Okay. Hopefully that was kind of clear, but I'll go through a bit more, a couple more examples. So return type. So in the beginning, as I said, in the beginning, you have to define what you want to return, right? In this case, I mean, in C++ or any language, you can have it whatever. Right? So you can have it return a double, a bool, a char, int, a double, whatever, I already said double. But yeah, so you can do whatever. But you can also have it return nothing, right? So that's what I mean by void, right? You can return any kind of thing, and you can return nothing. When would it be useful to return nothing? Talk amongst yourselves and give me a function that would return nothing. Alright, over here. What's a function that I would want to return nothing for? Ashura.
So if you do int x like that, and then
Give me the name of the function. Fraction?
subtraction.
Subtraction. Okay, why would a subtraction function not need a return?
Because if you do only int x, you have to
I like that logic. It would almost be right if it weren't for C++. Or, yeah, but it's okay. That's a great how you should be thinking. Actually.
Maybe it was like division and it was like something over zero.
You should be returning an error in that case. But no, I like how you're thinking. You guys are thinking in math terms. But what if you just wanted to do something, right? What if I have int A and int B, and what I want to do with the int A and B is just switch the values, right? Am I returning anything? Right? I'm not outputting anything, but I'm actually doing something to the values, right? I'm switching them, right? So that's the case when you want to do void. Or sometimes if you have a robot and you just want it to move from point A to point B, would it actually output anything? It wouldn't output anything, right? It only moves from A to B. Okay. So yeah. So point being is you can return nothing, and that would be void. Otherwise, you have to specify it's a double bool chart or whatever. So here's a pop quiz. At the beginning of all of your programs, you write int main parentheses brackets. What should you be returning? Talk amongst your neighbors and figure it out. Okay. Over here. So, int main, what should I be returning? Romeo. 0. Why? Huh? Yeah, I guess. Yeah, no, that works. But why 0 though? Why can't you just, I mean, you could just do nothing, but what is int main? Yeah. Integer, right? So int main is actually a function, right? But it's a function called main. So why do you call it main? Because in C++, when they're looking for a bunch of, like if you had like 10 different CPP files, it doesn't know where to start. So when it sees that word main, that's where it's going to start. So it doesn't matter what you name it, I mean what return type you give it, as long as you say like, you can have bool main or something like that. And as long as you have it called main, it's going to work. And what you should be returning, if it has int main, you want to return an integer. Right? So the reason why you want to return 0 is because in case if you do ever call the main function, it's going to say, yes, it executed or something like that. Okay, that might have been a bit complicated and went over your head, but it's okay. You guys don't have to know that quite yet. So, parameters. Can somebody tell me what is a parameter? Flo. Arrange something should be in. Very, very close. I like how you're thinking. That's exactly how you should be thinking, but not quite. Over here, what is a parameter? Boundary. That's kind of what he said. Make sure you're listening. Shoryun, what do you think? Not quite, not quite. So, parameters are our inputs. What are we inputting into the program, right? So, in this case, when we create a function called add, our parameters are x and y. Those are what we need to input in order to get an output. Okay, so so the thing about parameters, first thing you have to do is specify what it is, right? So you have int x or bool x or double x or whatever. So you have to specify what it is. And here's the special thing, and this is why you weren't quite right about the subtraction function. So scope. Can anybody tell me what does the word scope mean? Granted, you can see that, but but okay, whatever. So scope. What scope means is the range in which it exists in. So this is why I have two separate things. So I have int main and I have int add, right? So if I create an int x here, int add won't know what is x because it only exists in main. Does that make sense? I don't see a lot of nodding or yes or talking. So make sure you guys, if you guys are stuck on something, talk to your neighbors or something like that, okay? So if I create an int x here in main, int add doesn't know what's x, right? So then whatever you put in here, int x, int main doesn't know because it only exists in add. Does that make sense? Okay, so this is really, really key. So this is why you need to output something, right? Because it doesn't know anything. So in order for int main to know, you have to have it return something. So in this case, it's returning another integer, and then you can store int. What you can do is, what is it? Int y equals add 1, 1. Something like that. So this is how we're able to pass values into a different function, so to say. So you set it equal to another. You set it equal to another variable, and then it's going to store it in that variable. Does that make sense? Okay. Yeah, let me see. Okay. Wow, I was fast today.